Let me describe the worst version of your best product. You have a fried chicken piece that left the fryer 12 minutes ago. The crust was perfect, shatteringly crisp, deeply golden, seasoned exactly right. The interior was juicy, cooked through, holding its moisture the way good fried chicken should. Someone on your team looked at it coming out of the oil and felt genuine pride. That piece was exactly what it was supposed to be. Then it went into the holding drawer. And now, 12 minutes later, a customer opens the box. The crust is no longer crisp. It is soft in places, slightly leathery in others. When they bite into it, there is no crack, just a dull compression. The interior, which was juicy 12 minutes ago, is now noticeably tighter. The texture has changed from yielding to resistant. The chicken is, in the technical language of food science, rubbery. In the everyday language of a one-star review, it is terrible. Nothing went wrong in the fryer, everything went wrong in the drawer. Today we are talking about one of the most persistent and most misunderstood quality failures in QSR and food service. What happens to fried chicken between the fryer and the customer? And why the holding equipment that is supposed to preserve your product is very often the thing that is destroying it. Welcome to Season 2 of Plate Store Places. I am Rahul, chef, food engineer, and someone who has argued about holding drawer temperatures in more countries than most people have visited. 3 books for this episode. 1, On Food and Cooking by Harold McGee. I keep returning to this book because it keeps being relevant. McGee's chapters on meat and on heat transfer explain exactly what is happening to your chicken protein at a molecular level during holding. If you want to understand why muscle fibers tighten, why moisture migrates, and why texture degrades under sustained heat, this is the clearest explanation you will find written for a non-laboratory audience. 2. The Science of Good Cooking by the editors at a major culinary research institution in the United States. This book runs controlled experiments on everyday cooking questions and presents the results with precision and clarity. The sections on frying, resting, and holding temperatures for proteins are directly applicable to everything we are covering today. Practical, rigorous, and genuinely useful. 3. Meathead, The Science of Great Barbecue and Grilling by Meathead Goldwyn. The title sounds like it is about weekend grilling. It is actually one of the best books ever written on meat science, heat transfer, and the physics of cooking protein. The principles on carryover cooking, internal temperature management, and moisture retention in cooked meat apply directly to fried chicken holding. Read it, and you will never look at a holding drawer the same way again, right? Let us go inside the holding drawer. To understand what the heat lamp and the holding drawer are doing to your fried chicken, you first need to understand what made the chicken good in the first place. When you fry a chicken piece in oil at 165 to 175 degrees Celsius, 2 processes are running simultaneously and they need to finish in balance with each other. On the outside, the Maillard reaction is building the flavor compounds and the rigid, dehydrated starch and protein crust that gives you the crunch and the color. On the inside, the heat is denaturing the muscle proteins, changing their structure from raw to cooked, and driving moisture from the interior toward the surface and into the oil. The ideal endpoint is a piece where the exterior crust is fully developed and dry, the interior protein is cooked to a safe temperature with maximum moisture retained, and the two are in a stable equilibrium. That equilibrium exists for a specific window of time after the fry. How long that window lasts depends on what you do next. Now here is what holding equipment does and why it almost always does it wrong. A standard heat lamp holding setup maintains temperature by radiating infrared heat downward onto the food surface. A holding drawer maintains temperature by surrounding the food with heated air, sometimes with added humidity. Both are designed with one goal: keep the food at a safe serving temperature. Neither is designed with a second goal that matters just as much: maintain the texture integrity of the product. Here is the problem. The crust of your fried chicken piece is a moisture-sensitive structure exactly like the fry crust we discussed last episode. It is rigid because it is dry. Any moisture that reaches it, from the steam escaping the interior of the chicken, from the humidity in a holding drawer, from condensation on the surface of the holding tray, will begin to soften it. Under a heat lamp, the surface of the crust continues to dry, which sounds good, but the steam from the hot interior has nowhere to go except outward through the crust, which carries moisture through the very structure you are trying to keep dry. In a holding drawer with added humidity, a common feature designed to keep the interior of the chicken moist, you are actively introducing moisture into the environment surrounding your crust. You are hydrating the exterior in order to protect the interior. The interior stays juicy. The exterior becomes the texture of damp cardboard. And here is the protein problem, which is separate from the moisture problem and compounds it. Chicken muscle protein, once cooked, does not stop changing with heat. It continues to denature and contract. The longer a cooked chicken piece is held at temperature, the more the muscle fibers tighten, expelling the moisture they were holding and becoming progressively more dense and resistant. This is why a chicken piece held for 8 minutes feels different from one held for 20 minutes, even at the same temperature. The protein is still cooking, slowly, continuously, and there is no point at which it stops and reverses. The rubberiness your customer experiences is not the chicken drying out in the simple sense. It is the chicken's muscle proteins contracting to the point where they have expelled most of their retained moisture and become mechanically rigid. It feels rubbery because the protein fibers have lost their elasticity. They compress under a bite but do not yield the way a freshly cooked piece does. Temperature accelerates this. A holding drawer set too high, above 74 degrees Celsius, continues the cooking process at a rate that creates noticeable protein tightening within 10 to 12 minutes. A drawer set too low, below 60 degrees, creates a food safety risk. The window between safe holding and quality destruction is narrow. Most operations are not hitting it. Let me tell you about a fried chicken brand that was experiencing a very specific split in their customer feedback. Their dine-in reviews were strong. Customers eating in the restaurant were consistently rating the chicken well. Crispy, juicy, well-seasoned. Their delivery reviews told a completely different story. Rubbery chicken, soft crust. Chicken that tasted like it had been sitting for a long time, even when the delivery time was under 20 minutes. When we audited their operation, the first thing we checked was their holding protocol. They were using a standard holding drawer with the humidity function turned on because someone on the team had read that humidity keeps chicken moist, which is technically true and operationally catastrophic for crust integrity. The drawer was set to 72 degrees Celsius with active humidity. Their hold time limit was written as 30 minutes on their operation sheet. In practice, during peak hour, pieces were sitting for up to 45 minutes before they went into a delivery bag. 3 problems: active humidity destroying the crust, hold temperature continuing the cook on the protein, and a hold time limit that was a guideline rather than an enforced standard. We made 3 specific changes: humidity, function off, temperature reduced to 65 degrees Celsius, the lowest safe holding point for their product. Hold time limit reduced to 15 minutes with a physical discard protocol enforced during every peak service. The kitchen team pushed back on the 15-minute limit. The instinct in any QSR kitchen is to hold product as long as possible to avoid waste and refry time. We ran the numbers with them. The cost of discarding and refrying at 15 minutes was significantly lower than the cost of the delivery rating they were carrying. Delivery ratings affect platform ranking. Platform ranking affects order volume. The maths was not complicated once we laid it out. Within a month of implementing those 3 changes, their delivery reviews for chicken quality had shifted measurably. The crust problem was not completely eliminated, packaging still needed work, but the rubber texture complaint essentially disappeared. Here is another story from a hotel banquet context. Because the holding problem is not exclusive to QSR. I was consulting for a large hotel property that was running fried chicken as part of a wedding banquet menu. 500 covers. The chicken was being fried in batches, starting 2 hours before service. It was being held in large hotel bain-marie, steam table inserts over hot water, covered with lids to retain heat. When service began, the chicken that had been held the longest, the first batches fried, had been sitting in that steam environment for close to 2 hours. The result was not just rubbery. The crust had essentially dissolved. The exterior of the chicken was soft, pale in places, and had the texture of something that had been boiled rather than fried. The steam from the hot water below had worked its way into every piece over that 2-hour window and undone the fry completely. The head chef's defense was that the chicken was safe, the temperature was correct, the internal temperature was above 74 degrees throughout. He was right, the chicken was safe. It was also texturally a completely different product from what had been promised and what had been tasted during the menu trial. The fix for that banquet was operational rather than equipment-based. We staggered the fry schedule so that no piece was held for more than 20 minutes before service, which meant frying in rolling batches through the first 90 minutes of the event rather than producing all 500 pieces in advance. It required more organization and more communication between the kitchen and the banquet floor. It produced chicken that guests actually wanted to eat. The lesson was one I have seen play out in every context, from QSR to 5-star banqueting. Holding equipment is not a quality-neutral environment. It is an active force acting on your product. Treat it accordingly. And one more story, because this one has an unexpected solution that I still think about. A chef I worked with in the Middle East was running a very high-volume fried chicken operation. He had a holding problem he could not solve through temperature or time adjustments alone. Whatever he did with the drawer settings, the crust was softening faster than his hold time protocol allowed for. He tried something I had not seen before. He installed a small convection fan system in his holding area. Essentially, a very gentle airflow directed across the holding trays. Not enough to cool the product significantly, but enough to carry away the steam rising from the chicken before it could condense back onto the crust. The principle was identical to the vented packaging solution for fries, applied to the holding environment instead of the packaging. The results were significant. Crunch retention in the holding area improved by several minutes across every piece. The gentle airflow was removing the moisture-laden air surrounding the chicken and replacing it with drier ambient air, slowing the rate of crust hydration from the exterior. It was not a standard QSR solution. It required a custom setup, but the principle it demonstrated is universal. The air environment immediately surrounding your held fried product is as important as the temperature. Managing that air environment, rather than just the heat, is the next frontier for holding technology in QSR. So what actually works? Here is what the evidence consistently supports. Solution 1. Turn off the humidity function in your holding drawers for breaded and battered products. This is the most common and most damaging mistake in QSR holding protocol. Humidity is appropriate for holding products where surface moisture retention matters. Roast meats, steamed items, products without a crust. It is actively destructive for fried products. Your crust does not need moisture, it needs the opposite. If your holding equipment has a humidity function, it should be off for every fried product in your operation without exception. Solution 2. Calibrate your holding temperature to the lowest safe point for your specific product. The food safety minimum for held cooked chicken is 60 degrees Celsius in most regulatory frameworks. Check your local standard and use that as your floor. Every degree above that minimum accelerates protein tightening and moisture expulsion. The difference between holding at 74 degrees and holding at 63 degrees over a 20-minute window is measurable in texture. Find the lowest temperature at which your product remains safe and hold there, not higher. Solution 3. Define and enforce your hold time limit as an operational non-negotiable. The hold time limit is the single most important quality control mechanism in your holding protocol, and the single most commonly ignored one. Define the limit based on testing, not assumption. Fry a piece, hold it in your actual holding equipment at your actual temperature, and taste it every 5 minutes. Record when the texture becomes unacceptable. That is your limit. Write it into your protocol. Build a physical discard system, a timer, a color-coded label, a rotation rack that makes it impossible for a piece to exceed that limit without someone making a conscious decision to violate the protocol. Solution 4. Elevate your product off the holding surface and allow air circulation underneath. A chicken piece sitting flat on a solid holding tray is trapped. Steam from below the tray and steam from the piece itself have nowhere to go but up through the crust. Use perforated holding trays or wire racks that allow air to circulate above and below the product. This does not solve the problem entirely, but it significantly slows the rate of crust moisture absorption from below. Solution 5. Rethink your breading and coating system for hold time performance. This is a longer-term investment, but a high-impact one. A standard flour-based breading will degrade under holding conditions faster than a formulation designed with moisture resistance in mind. Adding rice flour, fine breadcrumbs with low moisture content, or a pre-dusting of cornstarch before your wet batter creates a more robust crust architecture that holds up longer under the thermal and moisture stress of holding. If you are producing fried chicken at QSR scale, work with a food technologist to develop a coating system that is tested specifically for your holding conditions, not just for its initial crunch out of the fryer. Solution 6. For delivery specifically, fry as close to dispatch time as your operation allows. This sounds obvious. In practice, it requires discipline that conflicts with the QSR instinct to hold large batches during prep. The closer the fry time is to the delivery pickup time, the less work your holding equipment has to do and the less damage it can cause. Build your production schedule around your delivery pickup windows rather than around your peak prep convenience. The product that leaves your kitchen closest to its optimal state is the product that arrives closest to acceptable. Quick facts before we wrap up. Fact 1. The optimal resting time for fried chicken before holding or serving is between 2 and 3 minutes. During this window, the crust continues to dehydrate slightly as residual heat drives remaining surface moisture away and the interior moisture redistributes toward a more even state. Placing chicken directly into a holding environment immediately after frying, with no rest, puts a wetter piece into the drawer and accelerates crust degradation. 2 minutes on a wire rack before holding makes a measurable difference. Fact 2. The color of your holding tray matters more than most operators realize. Dark-colored holding trays absorb more radiant heat from overhead lamps and transfer it to the bottom of the product, continuing the cooking process from below at a rate that accelerates protein tightening. Light-colored or reflective trays reduce this bottom heat effect. A simple equipment change with a non-trivial impact on hold quality. Fact 3. Consumer research consistently shows that texture is the primary driver of fried chicken satisfaction ratings. Ahead of seasoning, ahead of juiciness, and significantly ahead of portion size. Crunch is not a nice to have for your fried chicken product. It is the primary quality signal your customer is using to judge whether you are excellent, acceptable, or worth a 1-star review. The holding drawer is where that primary quality signal goes to die. Treat it with appropriate seriousness. Your challenge this week, I am calling it the #drawer test. This week, I want you to run a simple but revealing experiment in your own kitchen or with your next delivery order. Fry or order a piece of fried chicken and taste it at 3 specific points: immediately, at 10 minutes, and at 20 minutes. Rate the crust texture, the interior texture, and the overall experience at each point on a scale of 1 to 10. If you are an operator, do this in your actual holding equipment at your actual settings. If you are a food lover, do it with your delivery order and your kitchen timer. The results will tell you exactly how long your product or your favorite restaurant's product actually survives before quality becomes compromised. Post your 3 scores and your observations on Instagram or LinkedIn with the hashtag drawer test and tag me. The most methodical experiment and the most honest finding gets a shout out next episode. That is it for today. The holding drawer is not neutral, it is not passive. It is an active participant in the quality of your fried chicken, and right now, in most QSR and food service operations, it is working against you. Turn off the humidity, lower the temperature to the safe minimum, enforce the hold time limit, elevate the product, improve the coating, fry closer to dispatch. None of these changes require a new kitchen. None require a new recipe. They require the understanding that the fryer is only half the story. The holding environment is the other half. And right now, most operations are only managing one of them. Next time on Plate Store Places, we tackle topic 6, why food temperature drops before the customer even opens the bag, and whether the warm air inside your packaging has actually filed a restraining order against your food. Until then, respect the hold, manage the environment, and give your chicken the exit from the fryer that it actually deserves. I am Rahul, and this is Plate Store Places.